Section 1.3 gives us a start with the trig functions. And so the first thing that we want to really look at is the right triangle and on our grid here. So if we think about, here's theta, and that's just an angle. This amount here is x, because that's on the x-axis. And then going up, that's our y, if we have a point, P, which is x comma y. And R would be the hypotenuse of this triangle. So in this right triangle, we have x, y, and R. And we know that in a right triangle, x squared plus y squared equals r squared. That's the Pythagorean theorem. So if we want to know what r is, it's the square root of x squared plus y squared. So that's something we always need to remember. Now, in that triangle, the 6 functions are right here: sine, cosine, tan, cosecant, secant, cotan. Sine is y over r, opposite over hypotenuse. Cosine is x over r, adjacent over hypotenuse. Tangent is y over x, which is opposite over adjacent. When I taught high school, I sometimes used this acronym, talked about it being an old Indian legend. I don't know what story I made up, but at any rate, SOHCAHTOA. If you can remember the letters, it'll always help you, because the S, that's sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So that is a quick little acronym that might help you. All right, and we've talked about this once before already. In the unit circle, that's this little circle that's going around here, quadrantal angles 0, 90, 180, 270, 360. And let's see, a unit circle is a unit of 1 in its radius. So this is 1, 0, 0, 1, negative 1, 0, 0, negative 1. All right. This little chart begins to help us see the trig functions. And these are the most commonly used quadrantal angles. The sine of 0 is 0, the cosine of 0 is 1, and it goes through here. Now, you can find those on your calculator, but you have to make sure you're in degree mode. And that's about as much as we're going to get right there, and we do have some problems to go over with this. So let's go look at our problems. All right, so let's look at this first question. It says, sketch the angle in standard position so that it has the least positive measure and the point 3, negative 4 is on the terminal side. So what we need to get out of that is here we have a point 3, negative 4. Now if I plot that point 3, negative 4, 3, negative 4. See, think about it over here, over 3, down negative 4. That point is in the 4th quadrant. So this angle this is the only one that has the point in the 4th quadrant. This one's in the 2nd, this is in the 3rd. So the angle is that. All right. Select the correct choice. So it says, okay, for that angle, they want to know sine, cosine, tan. Well, here's my right triangle, and that's what we can always look at. My x value is 3, my y value is negative 4. I had to find my r. So that's x squared plus y squared is r squared. So that's 25 is r squared. Take the square root, so 5 is r. So I've got all my numbers here. Sine of theta, here's my theta, is opposite over hypotenuse, so negative 4 over 5. Cosine is adjacent over hypotenuse, so 3/5. Tangent is negative 4 over 3. Now once you get these three, all you have to do is flip to get the others. The sine goes with cosecant. So S goes with C. Just flip it, you get negative 5 over 4. Secant goes with cosine. Cosine, C goes with S. S goes with C, C goes with S. So you flip, and tan and cotan are easy to remember. And so you're just flipping the second set. Flip these first three, you get these three. All right? All right, so let's do it again. It's a little bit more involved with this one. So it says sketch an angle in standard position that has the point -3, positive square root of 2. We don't have to know exactly what square root of 2 is. We need to know that we have to go -3 on the x, up square root of 2. And then I figured out what r was. I squared the square root of 2. I squared -3. So you have a 9 and you have 2. So r squared is 11, so r is the square root of 11. So this makes the algebra a little bit more involved when we go to find sine and cosine. So sine for our theta is opposite over hypotenuse. Now, and I didn't have the square root of 11 down there. I didn't have the square root. Let me put that there. Okay. So you can't leave the radical in the bottom, so we have to rationalize. So we have square root of 2 over square root of 11 times square root 11 over square root 11. On the bottom, when you multiply a radical by itself, you just get the number inside. So we've gotten rid of the radical on the bottom. On the top, that we have square root of 22 over 11. So I guess I had put the final answer there. There we go. All right. For cosine, it's -3 over the square root of 11. So here we go. We got to rationalize. So we end up with -3 square roots of 11 over 11. For tangent, we've got this is negative, so the whole thing will be negative, but it's square root of 2 over 3, and I just put the negative out front. Then we're going to have to flip these, and let's see. Most of those were okay. For secant, secant goes with cosine. And so you want to go back to your original. You want to go back to your original. So here was the original. So if we just flip that, it's negative square root of 11 over 3. Cosecant is with sine. Here was my original. And so when we go down here, we have square root of 11 over square root of 2. Rationalize it, and you end up with square root of 22 over 2. Cotan, here's our tangent, negative square root of 2 over 3. So I flipped it. I rationalized, so we have -3 square roots of 2 over just a plain 2 on the bottom. So you have to do a little algebra stuff there, so keep that in mind. Suppose that the point xy is in the indicated quadrant. Decide whether it's positive or negative as a ratio. All right, so if we're in the third quadrant and we've got r here and x here, well, our r is always going to be positive. X, in this quadrant, x is negative. So the quotient, the ratio here, is ending up being negative. Because you have positive divided by negative, that will be negative. Okay? All right, let's look at number 4. Same kind of question. You're in, oh, our question is messed up. Hang on. Okay, so I think we can see number 4 now. So it says we're in quadrant 4. And so if we're in quadrant 4, let's see, if we're in quadrant 4, we're down here. And so x is positive, but y is negative. So we have, and we're talking about r. R is always positive. So positive over y, which is negative, so we will be negative again. All right, Let's move on to number 5. Evaluate for cosine of 90. Cosine of 90. Remember, those were, if we went back to our lecture notes, those were down in our little chart, and cosine of 90 is 0. So you'll begin to just know those. So we'll get that. But the cosine of 90 is 0. Okay. Now the sine of 180, if we go back and look, here's 180, sine of that is 0. So we'll go back here. That must be back here. All right. So find the indicated function value. If it's undefined, say so. 2520. So 2520, we want to think about 360 goes into 2520. If we did this, 2520 divided by 360, and it's probably going to go around 7 times. 0, 7 times 6 is 42. So yeah, exactly. So ultimately, it's the same as if you go around the unit circle, it's right here. It's the same as if it were 0 degrees or 360. And so the sine of that, let's go look at our thing again one more time. So the sine of 360 is 0. 0 and 360 have the same thing. So that would be 0. All right. Negative 1080, 360 goes into that 3 times. So it's the same as the tan of 0 or 360. And if we go back and look, tan of 360 or 180 is 0. So we've got that. All right. Now, you can use your chart as you are learning these. Sine of 180 minus 2 sine 270. So we're just plugging in that 0 minus 2 sine of 270 is negative 1. So that becomes a positive 2. So your final answer is 2. And then same thing here. Cosine of 90 is 0. Sine of negative 270 is negative 1. So 0 squared is still 0. Negative 1 squared is 1. So we get 1. So we're just beginning to use the basic trig functions in this section, and hopefully that will get you through section 1.3.